parts. First, we should clean water with cleaning and sewage system. And secondly, we should create an effective water quality monitoring system. The cleaning problem can be solved without software. That is why we concentrated on the monitoring problem. The most popular methods of water quality monitoring is chemical and spectroscopy. But these methods have some disadvantages. We can't monitor water in real time, and we can't monitor water over wide area. But ideal method should be work in real time and over wide area and remote sensing. And the aim of our project, the development of remote water quality monitoring system over wide area and operating in real time. And this method exists. This method is based on the polarization of reflected light. To demonstrate of this phenomenon, you have a piece of polarized film. If you look through this film through liquid crystal displays and turn it, you can see that intensity of liquid crystal displays changes. Are you seeing? Yes. Look at this picture. On the left, you can see that you can see a small contamination area. But on the right, you can see that contamination area is bigger because we look in polarization domain. Many years ago, people used the same method. People capture images in polarization domain, then they printed and digitized them, and then we made conclusions about water quality in this area. And we have automated this process. We created a unique hardware solution and a lot of software applications. We mount our device near lakes or rivers, and we capture images in polarization domain, and we transfer them to laptop, and where we analyze them, and then we make conclusions about water quality in this area. And let's look inside the system. We have a source of light, we have a glass with water, and we have our device, and we have a PolarVision analyzer. How does it work, I wonder?
Our device had greatly changed before looking like that, and the evolution of our project had several stages. As the first step, we created a ferroelectric liquid crystal cell, which is the basic element of our setup. After that, we built up first experimental setup, and the data acquisition and analyzing software was developed. With the help of this setup, we got first images in polarization domain. Then we integrate all optical elements in our tube. And using this device, we got polarization images for pure and polluted water. And now we are trying to minimize the size of our device. Let's turn to our device working in detail. The light reflected from water surface passes through amplitude phase modulator and is focused by objective on CCD matrix. The amplitude phase modulator consists of ferroelectric liquid crystal cell and polarizer. And the liquid crystal cell is driven by specially developed voltage generator, which is connected to laptop, and CCD matrix result is also connected to laptop and synchronized with the voltage generator. The geographical position of our system can be determined by GPS module, but it is needed to make more than 4 different measurements. It means that we must set another value of voltage applied to liquid crystal cell till we get more mathematical techniques for recognize of contamination. For example, it's Stokes formalism and least square method. The index's reflection depends on degree of polarization, and the contamination time can be determined by dispersion curve, which is unique for every material. But all of this useless without software.
So, our system consists of several applications. And first of all, this is a PolarVision analyzer. This is main project. This all our system based on this. PolarVision analyzer allow to control the liquid crystal cell, receive information from CCD matrix, and create image in polarized light. This process is very difficult, and we use NVIDIA CUDA for accelerate this and to guarantee real-time regime. And now let's look how this works. Our project worked, and I start to control this.
Okay, you see that we have different frames and the intensity is changed. And then we make calculation and different filters of images. And you see that two different areas of water. And I want to present our previous results. In these cases, we use pure and contaminated water in the different glasses. In one of them was pure water, and in another was contaminated water. We use ethanol as a contamination, and concentration of ethanol was 10%. As you see, we can recognize mixed and unmixed contamination. So then the contamination was recognized. Please click on the oil. This is the case of oil contamination. We contaminate water by this oil, and then information transmit to data and will be available